Hi, welcome to Hashtag Math. We're going to obtain the equation that defines the function from a given graph. After all the hard work we've done, this is going to feel easy. It will all make sense. We want to identify the equation of the function whose graph is given here. So we want to find an equation for f of x. Being a rational function, we must remember that the numerator contains the factors corresponding to the x-intercepts, and the denominator is formed by the factors coming from the vertical asymptotes. And then we have to multiply by a number a, which determines the stretch or compression of the function. So the equation of f of x is going to be a number times a quotient. We start at the numerator, identify the x-intercept is at -4. The corresponding factor is x plus 4 because -4 makes it 0. For the denominator, we look at the asymptote, which is here at -2. The corresponding factor is x plus 2. To know the multiplicity or the power of the factor corresponding to -2, we look at the behavior of the function. When you approach -2 from the right, it goes to positive infinity. From the left, goes to negative infinity, so we change the signs, and the power should be 1. So far, our function looks like f of x equals a times x plus 4 over x plus 2. And the last piece of information to get the equation is the y-intercept here, which is at 2. That tells us that the function evaluated at 0 is 2, the y-intercept. So we plug 0 into the function, which is a times 0 plus 4 over 0 plus 2, and that must equal 2. So this is a times 4 over 2 equals 2, or a times 2 equals to 2, and when you divide both sides by 2, we get a equals 1. We substitute the 1 here for a, and our function is just x plus 4 over x plus 2. One thing to check at the end is the horizontal asymptote, which in this graph is here. The horizontal asymptote is y equals to 1, and let's verify that on the equation here. The leading coefficient of the top is 1, the leading coefficient of the bottom is 1, and the horizontal asymptote is going to be 1 over 1, which is 1, and everything makes sense. Let's go to the next example. To identify the equation of the function g of x corresponding to this graph, we do the same. G of x must be equal to a number, the stretch or compression of the graph, times a quotient. X-intercepts for the numerator, asymptotes for the denominator. For the numerator, we look at the x-intercept, which is here at 2, and the corresponding factor is x minus 2. To find the denominator, we look at the vertical asymptote, which is here at 3. The corresponding factor is x minus 3. To find the multiplicity or power of this factor, we look at the behavior of the function towards the asymptote x equals 3. And we see that it approaches the asymptote in the same way, both sides going to positive infinity. That means that the multiplicity is even, so we write a 2. Okay, so far our equation is a times x minus 2 over x minus 3 squared. The last piece of information that will allow us to find a is the y-intercept here. This tells us that g evaluated at 0 is -2/3, and so we plug in the 0 in the function. We get a times 0 minus 2 over 0 minus 3 squared equals to -2/3. So a times -2 over 9 equals -2/3. And to solve for a, we multiply by -9/2, the reciprocal. That cancels, of course, then a equals negative and negative is going to be positive. The 2 cancel out, so a equals 3. And the equation of the function is going to be 3 times x minus 2 over x minus 3 squared. It is a good idea to check our horizontal asymptote. The horizontal asymptote for this graph is here, is y equals 0, the x-axis. Does our equation have the same horizontal asymptote here? Yes, the degree of the denominator is bigger than the degree of the numerator, so everything makes sense. Another example, to find the equation, we do the same. H of x equals a times a numerator and a denominator. For the numerator, we look at the x-intercept, which is here at -2, and the corresponding factor is x plus 2. For the denominator, we look at the vertical asymptotes. Here, that one is -1. The corresponding factor is x plus 1. And the other asymptote is here, that is 2. The corresponding factor is x minus 2. The graph approaches both asymptotes changing signs, opposite directions. So the exponents are odd, 1 and 1. So far, the equation looks like a times x plus 2 over x plus 1 times x minus 2. To find a, we use the y-intercept, which is here. That tells us that h at 0 equals -1. Then we plug in the 0 in the equation. A times 0 plus 2 over 0 plus 1, 0 minus 2 equals -1. And so a times 2 over -2 equals -1. 2 over -2 is -1, so -a equals -1. Then a equals 1, and the equation of h of x equals x plus 2 over x plus 1 times x minus 2. We can check the horizontal asymptote. Here is y equals 0, and that matches with our equation because the degree of the denominator is bigger than the degree of the numerator, and that's it. So I'm giving several examples here. Let's look at one more. Identify the function f of x. We start the same way. F of x equals a number, stretch or compression times a quotient. For the numerator, go to the x-intercept, which is at 2, corresponding factor x minus 2. For the denominator, we see the asymptotes. One is here at -1, corresponding factor x plus 1. The other asymptote we have is here at 3, corresponding factor x minus 3. And then we look at the multiplicities. The graph approaches the asymptote x equals 3 in opposite directions, so the exponent must be odd, and we write a 1. The graph approaches the asymptote x equals -1 to the same direction. That means the exponent is even. We write a 2. So far, the equation looks like a times x minus 2 over x plus 1 squared times x minus 3. And the last piece to find a, we look at the y-intercept. We just got a y-intercept there. Haha, that was the last piece to be able to find a. The y-intercept tells us that f of 0 is 1/3. Plugging 0 into the equation, we have a times 0 minus 2 over 0 plus 1 squared times 0 minus 3, and that equals 1/3. That is a times -2 over -3 equals 1/3. Those two signs make a positive sign. Multiply by 3/2 both sides to solve for a, and we get that a is 1/2, and the function equals x minus 2 over the 1/2. I'm going to write the 2 down here. So it's 2 times x plus 1 squared times x minus 3. That's the equation. The horizontal asymptote of the graph is y equals 0, which matches with the equation we have just found because the degree of the denominator is bigger than the degree of the numerator. Good. Let's work our last example. We proceed the same way. Let's give this function a name. Let's say g of x. To find the equation of g of x, we write a times a quotient. For the numerator, we look at the x-intercept, which is here at 2. The corresponding factor is x minus 2. For the denominator, we look at the asymptotes, and we have 2. One here at x equals 1, corresponding factor x minus 1. Behavior towards the asymptote is changing signs, so we write a 1. The other asymptote is here at 4, corresponding factor x minus 4. The behavior towards the asymptote is changing signs, so we write a 1. And we notice that there's another piece of information in this graph. Here, this graph has a hole. It's happening at -3. What does that mean? In my equation, there should be a factor of x plus 3 canceling out in the top and in the bottom. So we need x plus 3 in the top and x plus 3 in the bottom. Now that makes sense. That produces that hole at -3. So far, the equation looks like a times x minus 2 times x plus 3 over x minus 1 times x minus 4 times x plus 3. To find a, we look at the y-intercept, which is here, and that tells us that g at 0 equals -3. Plugging the 0 into the equation to get a times 0 minus 2 times 0 plus 3 over 0 minus 1 times 0 minus 4 times 0 plus 3. And that equals -3. Of course, these two cancel out. So we get a times -2 over, when I multiply this 2, what we get is +4 equals -3. which is a times negative 1/2 equals negative 3. Multiply both sides by negative 2 to solve for a. So a equals 6. And the equation of this function is going to equal 6 times x minus 2 times x plus 3 over x minus 1 times x minus 4 times x plus 3. Again, we can check that the horizontal asymptote matches the equation. Here's the horizontal asymptote for the graph, y equals 0, and that matches the equation because the degree of the top is 2, the degree of the bottom is 3, and 3 is bigger than 2. We are done, and we finish a complete series of 8 videos on how to graph rational functions. Hard work, but we're done. Now it all makes sense.